Hello, everyone. We have an amazing show for you this week. First off is the Inflation Reduction Act. How big of an impact will it have on global temperatures?
And the team jumps up to Oregon to talk about some bolts coming out of a blade root and the blade coming off to the ground on one of PGE's sites up there.
And finally, we head to Norway, where there is a new startup making a vertical axis wind turbine for offshore that has some interesting design features that we'll talk about.
I'm Alan Hall, and I'm here with my good friends Rosemary Barnes and Joel Saxon. And this is the Uptime Wind Energy Podcast. Hi, guys. The Biden administration has made a lot of claims about the Inflation Reduction Act. And Michael Schellenberger, who is basically an environmentalist, but he also is an engineer, and he writes a lot about the environmental changes that are happening and what we can do about it and sort of the cost reward side of the equation. So he had an article he put out, and it was talking about the effect of the Inflation Reduction Act on temperatures. And is it really going to make that much difference? And the article is interesting. You know, I can't validate everything that Michael says in his article, but let me give you the pieces of it. So the U.S. is saying it's going to reduce carbon emissions by 2030 around 40% below 2005 levels. I think that's true. It's just less than the 50% that the Biden administration has been talking about. So they kind of gave themselves a haircut on reaching the 50% point. And the U.S. has substantially reduced emissions by using natural gas. And so we were already on a pathway to get to lower emissions just by converting over, stopping coal, using more natural gas would have been the pathway. So if we didn't pass a law, we would have already been at sort of 30% of those levels. So we've been knocked down by 30%, which is most of the way to 40%. And with this new law, they're figuring that Michael's saying that's going to add another 7%. So instead of 30%, we're going to 37%. And we're going to lower the temperature down in Fahrenheit by like 1/1000th of a degree Fahrenheit by the end of the century. So for $400 billion, we're going to make 1/1000th of a degree change. And also on sea levels aren't going to change that much. Based on the predictions, you put it into the model, the UN model, and spit out the numbers, and it doesn't really make that much difference. So it's interesting how the administration is talking about this Inflation Reduction Act having a big impact on CO2 reductions, which it will in terms of relative to the United States. This is sort of the Rosemary effect, right? You can always decrease, but what's the effect? And the effect is almost nothing. It's tiny. It was shockingly low. And Rosemary, I know when we've talked about this about a week ago, actually, of what some of the biggest impacts are. It doesn't seem like for it's actually the actual cost is $369 billion. It doesn't seem like there's going to be a lot of big changes in CO2, and we're not going to change the environment all that much. Does that make sense to you?
Well, to me, I think it's kind of beside the point if you try and calculate the actual temperature reduction of, first, any one country's effort, but second, any one specific program. What I think is cool about a lot of the aspects of this program is that it's going to, provide support for these early industries, I guess. So, when you look at technology adoption curves, it always starts out really gradual at first and then ramps up. And there's so much learning that needs to be done in this kind of gradual adoption phase. And in that early part as well, the business case isn't usually that compelling for, a lot of mainstream or large companies to get interested in it. So I think that this is going to help accelerate the way through that gradual part and get us closer to the really, steep part of the adoption curve. So, an example would be with EV charging, where at first, it's really hard to, for a company to make money off EV chargers because there's not that many electric vehicles on the road yet, and so they're not used that much. But you need a certain number of chargers before it becomes, a convenient enough experience that people in the mainstream are going to want to swap over. So I think that, you provide early support and then you can get over that threshold to where it becomes a really attractive technology choice between the clean one and the, incumbent dirty one, and that you can really, fast forward. And I think when you see the big, emissions reductions, the big percentages, and, that I guess for a country as big as the US, that will translate to some real, noticeable degrees difference or percentages of a degree difference to the climate. That's going to happen when the commercial aspect of it is there and it doesn't need the government support anymore. So, yeah, I would never really expect that the government is just going to pay for emissions reduction. I think that that's kind of like, I don't know, early 2000s kind of thinking, and it didn't really get us anywhere because it's just, as you've noted, it's so expensive. For every, 0.01 of a degree reduction comes with this immense bill for a government that's just trying to brute force their way into an emissions reduction. So I think it has to work like this. Right. And I think I think that it has the potential to do something meaningful, even if you add up the degrees that will be reduced from the program. Doesn't sound very impressive, but, think about the effect in 10 years' time when there's, a lot more companies that are, making money off clean products. So because they're just better than the dirty ones. I think that, that's the real impact.
And Joel, you've been across the United States quite a bit. And me personally, we just drove across the United States from Massachusetts to California. And the United States is immense. So unless you've made that journey, you don't really realize how much energy the United States uses. And in particular, we were paying attention kind of like on some of Rosemary's trips of the number of wind turbines, where they're located, where are the substations, where are the big transmission lines across the United States, where are the energy producing sites, natural gas burning sites in a lot of cases. There's just so much infrastructure. If you want to change that over, and back to Rosemary's point, if you haven't gone to Rosemary's Engineering with Rosie and listened to the discussion about charging sites for electric vehicles and how big of a problem that is in Europe and even in Australia, and I'll give you the United States too. Joel, it doesn't seem like there's $370 billion is going to make a drop in the bucket. Yeah, we're just so massive, right?
Because there's so much to do. I think if we look at the Inflation Reduction Act as like this end all be all fix it tool, that's not what it is. If we look at it more like a catalyst, right? If this thing is a catalyst to jumpstart some innovation, to jumpstart some people throwing money at different things to get up and running. Now, like Rosemary is saying, it might, with the PTC extensions and things like that, like it will get more development in place, and we'll be able to get further down the line towards, reducing, these 40% goals and 37% in reality of, as this article states. Right. This catalyst will get us towards those things. But I think I like the idea as well of thinking maybe the United States on the world stage can be looked at as, we're not normally looked at as the people starting the green energy revolution. But maybe this can do some of that. Maybe we can set some examples of, hey, this is what's going on, right? The point, the 1,000th of a degree change, it's better than looking at some of the other stats that say 3 degrees of increase. So we're one country in the world throwing a large sum of money, $400 billion at a problem as a catalyst, and maybe some other countries will follow suit. Some other things will happen. Some innovation here will spur some innovation somewhere else. So it's a group effort. It's not just the U.S. trying to fix the world problem too,
And I think you actually touched on Michael Schellenberger's ultimate point in that article, which was if we actually took some of that money and put it into R&D, it'd be of better use than trying to implement at this stage. And I think Rosemary is saying the same thing of we're still early. So. We still need to propagate out things. You don't think so? Because I'll give you the example,
we have
right?
The technologies, it's the implementation and getting the business cases workable that then leads to the scale that you need to go up. R&D, it's always, 20 years in the future that you see something that might be able to be commercialized. But the bulk of emissions reductions can happen using technologies that are well known to us. And it's just, like needing to get over that little hump. I mean, you would have seen it with wind energy, right? Like in from 2000 to 2010, things moved slowly because it was more expensive. It was, it was more of a pain. And then as soon as it got to the point where actually wind energy is a great way to make money, then you have all sorts of developers rushing in, bringing in experience from other fields. And, you can't get projects in the ground fast enough because it just everybody wants a piece of that pie. And so we just need to see the same thing replicated with all of the other clean energy technologies now. We've done it with wind and with solar.
So what if we shoved some R&D funds into some projects that were like TRL 7, TRL 8 instead of TRL 3? Right. Like we've been, Alan, you shared some stuff today. We were talking about in the group about some different algae projects and things like that. Like there's some of those technologies that are like, they've been kind of being played with for 10, 15, 20 years. And now they're almost commercialized. It'd be nice to get some of those over that last hurdle and in the field.
Yeah.
I think that's appropriate, especially where, some technologies are just never going to be cheaper than the polluting, emitting, version of it. And so I think that those, support the development because there's nothing in it for a private company to do that. And so a mix of that and then plus stuff that's at, 8 or 9 and just needs that last little bit to get to scale and commercial rollout. I think that would be a good mix. So, yeah.
I think that's what the ARPA-E projects are a lot of them are like that. They want to see some stuff that's in the 7 and 8, for those who don't know, TRL, technology readiness level. It's the U.S. government's scale of where an innovation is at to hit the field. 1 through 9. 1 is an idea. 9 is commercially scaled.
Making money, ideally. And back to Rosemary's point, the production tax credit probably had more to do with deployment of wind than anything else. I think we're going to see that again versus some of these other projects they're trying to take on. If you want to push wind, I think that's great. It seems like you do it cheaper. And I think the arguments that a lot of the states are using right now is saying, well, we've been putting money into wind for 20 odd years. Why do we keep doing it? And the answer is obvious, right? Because we want to try to, wean ourselves off foreign oil, all the stuff, right? All the above, right? Is it worth it? Don't know. I don't know if there's a good answer.
I don't think that wind needs a lot more subsidies in most places. I mean, Australia didn't have any kind of production tax credit. There's some renewable energy certificates, and I guess they still exist. But the real incentive is just that you can make a lot of money from a good wind project in Australia, and it really does stand on its own 2 feet. Definitely, I mean solar as well. I keep on talking about wind because that's obviously all of us are more involved in that part. But
well, sure. I think I know, and you see a lot of. We drove across the United States. We were listening to a lot of different things. We had a lot of seat time. I think there's just a big concern of we don't have any wind manufacturers in the States necessarily. I would count GE as sort of in the States, and solar, pretty much none, right? So if we really want to stand those things up, we got to get on it. And in that part, I think makes sense. If you want to stand up wind energy companies that could manufacture turbines in the States, that would be something that needs urgency. We don't need to have that 10 years from now. We need that in the next 24 months, I would say, if we're really serious. Now, it's going to be hard. I think it's going to be hard to tell if the Inflation Reduction Act is going to be making a dent in 24 months.
If you were to signpost, Alan, one thought of why the U.S. doesn't have a wind turbine manufacturer, what would you say it is? China.
And the availability
competitiveness.
It's cost. It's cost. Yeah. And the Danish have the same problem. The Germans have the same problem. It's cost, right? Everything gets outsourced. Even a lot of the Vestas wind turbine components and Siemens Gamesa wind turbine components are not in country. They're made outside. Right. And I think the supply chain to China is a big draw to lower the cost down because the operators want lower cost turbines.
Yeah.
Sure, why not?
Yeah, I've seen an article today that just said something about onshoring a lot more manufacturing. Like there's more new manufacturing facilities being built in the U.S. today than there has been in the last many years. So maybe that maybe that'll come from policy changes and things, and maybe we see something start up, or someone onshore at least bring the factories back over here and start those back up.
Yeah, I think the Biden administration is going to have trouble if they don't have physical
production. Yeah,
on the ground in visible spots. Mm-hmm. It's going to bounce back on them in a hard way. And they're promoting that. I think that's what they're trying to get to, but they have to make it reality, and which is the hardest part. As engineers, we all know we can all make computer simulations of whatever we want to, but building a factory and delivering wind turbines out of it is extremely difficult.
Now, the one feather in the cap they've got is the Jones Act is sitting out there, so at least some of this money is going into vessels that are being built here at the coastal port communities, But other than that,
well, that's a really good question, Joel. Do we need a Jones Act for wind turbines?
Competitiveness again. I think it would be nice. It would be really nice. It'd be nice to have a Jones Act for car parts. But now
solar panels.
Yeah, but now your $50,000 car will turn into a $100,000 car if every component has to be made in the U.S. So it's a global economy, global supply chain thing. Yeah, it would be fantastic if they have it. I would love if the government, if this $370 billion, if they said if you started a renewable energy manufacturing facility, design, manufacture, build facility, and you got a massive tax break, I think that would be fantastic to bring it onshore just for energy security purposes.
Mm. And ultimately, I think that's what matters, right? We don't need a wind turbine spurt that doesn't have lasting legs to it.
Yeah.
If we're going to do this and put this effort into it and spend hundreds of billions of dollars and the effort, we ought to have something that goes on more than a couple of years, ideally.
No, the investment might be better there into distributed power generation, photovoltaics, right? All solar power, because it's just easier to deploy. Maybe we need to bring that more onshore.
Get the latest on wind industry news, business, and technology sent straight to you every week. Sign up for the Uptime Tech newsletter at weatherguardwind.com/news.
All right, Rosemary, GE wind turbine dropped a blade out in Oregon. Now, you would say if that happened in Texas, I don't know if anybody would really care all that much. But in Oregon, for whatever reason, it's a huge deal. So as the story goes, a blade fell off or was thrust into the air and then landed in a field without injuring anybody. Well, it could have injured somebody. If somebody was standing right there at 2 a.m. in the morning watching the wind turbine, they could have been hit by a flying blade. The news articles you see are very inflammatory. The language is so suspect, it makes you wonder what the agenda is. But because clearly the agenda is we don't like wind. We don't like PGE, which is a power provider and which has operating a little over 200 wind turbines out in Oregon. And we want all this stuff to stop because for whatever reason, I'm guessing Oregon, which is one of the most liberal places on the planet, doesn't think wind energy is cool. And
depends where it was in Oregon.
Yeah, right.
If it was against the coast, it's one. If it's in the middle, it's a different story.
That's true. If it's on the eastern side, not cool, right? Wind is not cool. On the western side, wind is cool. At least you think it would be. Mm-hmm. But the issue with this particular wind turbine is the bolts started falling out of the blade, and some of them were on the ground. Not a salesperson, but a delivery person was up that way and was maybe taking a lunch break, what it sounded like, and saw some bolts laying on the ground. And he took a picture of one. He picked one of them up and kept it as a souvenir, as a paperweight, and that was it. And then 2 days later, boom, the blade flies off. Shocker. And the local community and regulators are super concerned about it. I guess that makes sense. And PGE pretty much stopped everything, shutting down all those wind turbines, a little over 200 wind turbines, and then checking the blade bolt torque. And they kept four shut down for a little while longer. I assume they found some issues with those. And I had talked to EchoBolt a couple of months ago off behind the scenes there. And when I asked those guys, talked to Pete there, and what they said about bolts was, I said, what are the critical bolts joints in a wind turbine? Because their company measures bolt torque or bolt tightness. And he said, because I thought it was foundation bolts. No, it's blade bolts. It's definitely blade bolts because of the coefficient of thermal expansion. Fiberglass doesn't move, the bolt moves, things tend to loosen up over time. And I thought, oh, yeah, that makes obvious sense. Come on, right? So Rosemary, on those, because you're our blade expert, does that whole joint make sense where you put these big metal bolts and you tap it into fiberglass and that's what's holding the blade onto the hub? Does that design make sense?
It's a really tricky design aspect. I don't think they usually tapped in. At least I haven't seen it done that way. You would usually mold them in there. So you put some material around it, and then as you're curing the blade shell, you cure it with bolts in there, or with some component in there that the bolts are going to thread into. Because if you're trying to tap into the fiberglass, that's tricky, because you're going to be cutting as you cut out the path for the thread. You're going to be slicing through the fibers, and you're going to be just transferring purely through the resin, which is not ideal. But I mean, it's not ideal anyway. They're two totally different materials with different properties, not just the thermal coefficient of thermal expansion is different. So yeah, the bolts probably, their volume changes more than the blades with temperature changes. Then also the stiffness is different between the two materials. So you're going to get stress concentrations around it. It's a really challenging feature, and every manufacturer has come up with a slightly different way to do it. And when there are issues from time to time, probably with every manufacturer, and when there's issues with with something related to the way that the blade is bolted into the hub, those are big problems that the companies need to take seriously. But in this particular case, it doesn't sound to me so much like a design problem as like a maintenance problem. I mean, if you read through the article, there's been, a history of poor maintenance and things being covered up and turbines continuing to operate even though there's been, more than one blade bolt failure. I mean, I know they'll be designed with safety margins. So, in theory, you can have, one or several bolts could break and the design is still safe, but you do have to start thinking, why did this one blade bolt break, and are other ones going to also break? And it doesn't look like they really, displayed the necessary level of curiosity and didn't, make sure that the maintenance was done adequately to ensure that this sort of thing couldn't happen.
Joel, is that something that is regularly inspected?
Yeah.
The bolt tightness on
the
blades?
I'll give you, there's just a couple ways to look at it as well. So think about, we were talking earlier about you building some IKEA furniture. When you put together the corners of some of your IKEA furniture, there's a hole that you drop a barrel nut into, and then you screw in this way, and that barrel nut goes like this and pinches it together. That's the design that's replicated in a lot of root bolts. There's a void around where where you would put a threaded bolt in. And then you cast the blade, you do everything, and then you drop that in there, and then come in the other way with a threaded rod, thread the rod into the barrel nut, and then you epoxy it in. So now you have it's setting against all the basically all the huge plies and materials at the end of the root bolt. So sometimes when they start to loosen up, that they start to kind of vibrate, shimmy a little bit, and that bolt can like wiggle inside of that cavity, and then you get a crack in the gel coat. So you can see that a lot of times on external inspections, right? Like the GE 15s, that's how they were built. And if you look at them, you can see that sometimes if the turbine's 10, 15 years old, if that gel coat is cracked and a little bit of water has gotten into where that bolt is, and sometimes they rust, and it looks like little rust pockets. Let me take that back. Yeah. I said GE, I meant Suzlons. Suzlons are built like that. So they'll have like a little bit of like rust crack that is around right at the root. And you can see it from an external drone image from the outside. That's even without going up and tensioning bolts and all that stuff. Like you can catch it on normal inspection if that's the way it happens. But then once those get loose in there, they start shimmying and moving around and shaking, and then you start loosening the whole blade up,
The bolt image that was shown with this article looked like the bolts were rusty.
Yeah.
I thought that's, up in Oregon, it's wet all the time. It's probably a little bit salty. What are the chances that the bolts are rusting? Probably pretty high.
Well, it's the same.
Is it more of...
It's the exact same thing you're talking about. It's the coefficient of thermal expansion, right? So if the steel is moving at one rate and the fiberglass isn't, and it's galvanized, well, it's great that it was galvanized when it went in, but it's going to eventually rub that galvanization right off that bolt. It's not the reason that you put metal in concrete is because the coefficient of thermal expansion is the same, or basically the same in concrete and steel. It's not the same in a composite blade root end and steel, so they don't play well together. So it's something you got to keep an eye on. Definitely, we catch it. I've seen the guys on my team catch it in reprocessing inspections, where they say, "Hey, this was missed. Look at the root bolts. You have to go do an investigation there." And sometimes a rope crew will need to go up there, grind the gel coat off, so they can actually look at the problem and see, because in that pocket, the actual root sometimes can crack of the composite rather than the bolt itself. And then you got to do a deep repair to fix that.
Yeah, is that even fixable?
Yeah. But I mean, at some level, it's not, right? But if you catch it early enough, you can,
right?
Yeah, you can catch those things in vibration alarms as well. Because if they start getting goofy, and because what ends up happening sometimes is then if one side starts to loosen up of the root bolts, and then they start the tip angle gets a little bit weird on one blade, and then the whole thing starts to vibrate, and you can catch it beforehand sometimes. That's what we were the other week talking about the guys at AC 883 doing the pitch alignments and whatnot. You can catch it with that.
Right. Yeah, true.
Yeah.
Rosemary, has there been more recent design changes that get rid of some of these failure modes at the bolted connection?
I mean, there's several ways to do it, and I actually haven't worked so much with that IKEA bolt like design. There's a few other ways, and any of them, all of them can have problems. But I really think that this is a cautionary tale for why you need to spend the money on maintenance after you've bought your wind farm. Because if you read through, the list of issues with this particular wind farm, it's got way more maintenance issues than comparable wind farms. I think it mentions like 3 times or something the level. Mm-hmm. And also the power production has declined a lot over the last few years as well. So it just suggests to me that, I have worked with owners, with operators that didn't think that they should have to spend any money on maintenance. And wind turbines do need maintenance. I mean, it's just that's just a feature of the technology. They need maintenance. And if you don't do it, then, that's a great way to save money for 5 years. Maybe it's a great way to save money for 10 years, but these ones are at 15 years now and they're talking about replacing them. And it really sounds to me like it's because they just haven't invested in preventative maintenance. And you need to, if you own a wind farm, you need to maintain it. That's the lesson that we can draw from this, I think.
Sticking with Rosemary there, and because we run into this when we do root cause analysis cases a lot, is the asset owner has entrusted a lot of times the OEM under a full service agreement. And they're like, we pay them to do the full service agreement. We shouldn't have these issues. You can see in this case that, yes, they did that, but if it still vests with the full service agreement, which is what it sounds like, they should have, once in a while had someone else stick their nose in there, maybe do an inspection campaign on their own, just to make sure that they're QCing their full service agreement.
What do you think about these OEM service agreements, Joel? Because that's something that is a real feature of Australia. Pretty much every developer here is using OEM service agreements. And I know I only get brought into these cases when there's a problem, so maybe I have a pessimistic view of it, but I see nothing but difficulties when, the owners of these assets are kept totally separate from what's going on with their very, very expensive asset. They don't have information about what's going on. They don't have the right to monitor it. They don't, it's a weird system, and I would feel very uncomfortable if I owned a wind farm and didn't have the right to know what was going on with my assets.
Right, with I believe the term is nepotism. It's the same thing when we were in the oil field. If you had an inspector working for you that worked for you inspecting their stuff, what is the what is the advantage of them blowing a whistle or anything? There isn't one, right? A good thought here. I worked in the civil engineering world in Illinois for a while. Illinois has a very tough hierarchy on how public works projects are done. So in each public works project, if the state of Illinois was doing it, they would have a construction company. That construction company could not also do the drainage works. It had to be a different one so that they couldn't cover up each other's mistakes. And then the third party had to be an independent consulting engineering firm, because that independent consulting engineering firm would act as the bird dog for the state and make sure that everybody was doing the things they were supposed to be doing. So it's the same thing like you say here. You have someone selling you the product, and then they're also going to maintain it. And in the language, they have stuff in there that says, you don't get rights to our inspections. You can't put people up tower. Like there's some weird stuff in there, right? But some of it gives this like feeling of this warm and fuzzy feeling to the owner. Like, well, this is great. All we have to do is get permits to build this thing. They'll build it. They'll manufacture it. They'll maintain it. And we collect the money. Well, I would urge you to read deeper.
I think they think it's a way that they can avoid needing any technical expertise on their team. Because I know in Australia, we don't have a lot of engineers that are experienced in, designing, manufacturing, servicing wind turbines. It's new, all of that. I mean, service actually is probably wrong. We've got good service industry now. But so the developers and the operators, the operators, they choose the OEMs to do that because they don't have that expertise and they don't want to have to get it. It's hard to come by. And so you end up with these agreements, and their only protection really is, an availability guarantee, an uptime guarantee. And so the company with a service agreement, all they've got to do is make sure that, you don't drop down below that minimum level of uptime. And if there's a problem that is, going to have less downtime than that, they've got no incentive to fix it. But it's the owner that is going to see, reduced checks coming in because there's problems that could have been fixed faster if someone had an incentive to. But I don't know. It seems all a big mess to me.
I'd like to see the industry or the market respond heavier with independent full service agreement contract, like Deutsche Windtechnik, right? They do it. Mm-hmm. I'd like to see more opters, because I reside in the blade space. So there's a lot of blade repair companies out there. There's every corner of the globe has them, but there's not a whole lot of companies capable of taking on a full service arrangement. I know, like I said, Deutsche Windtechnik comes to mind because they're the biggest one I can think of right now. But I'd like to see more of those, that when the warranty end runs out on a turbine, that's when their full service agreement ends with the OEM and they can switch to someone else, because there might be better language, better contract, better legalities.
So when does the government step in? When does the state step in and start checking up on these sites?
Oh, for sure. If there's safety issues.
Isn't that inevitable?
Yeah. In this.
You think OSHA.
Yeah, but OSHA is only involved if there's been a person injured, typically, or something that could have seriously injured people. But I mean, in this particular case,
you've got times. I know some roofers in Minneapolis that OSHA literally came through and fined every roofer in an area, as inspectors came and looked and saw they weren't using the proper tie-offs, right? And they were just like writing up fines, Yeah, exactly. But for things like this, such as something like this, that's so highly visible, and it's a hot button topic, you would think that, that's the only agency I could think that I would have any power there anyways, Occupational Safety and Health Administration.
Well, we're in California at the minute, and California's going through a little bit what they call the heat wave, where it's mid 90s. Maybe it reaches 100. It's not Texas hot, it's California hot. And they're telling people to turn off air conditioners and to not charge your EV. That all makes sense to me. But if you have a variable like wind turbines going down because of poor maintenance, the state has to step in. Politically, they have to step in and at least throw some bodies at it. because you can't lose them right now.
We walk back to the thing we've been talking about for the last 3 weeks is the 42% guarantee from the government for Dominion.
Yeah. That's such a mess.
Well, you get into the same thing. It's
Rosemary's so
uptime.
against it, but I think she's right.
Yeah.
No, Rosemary's totally right about that, right? She's totally right. But I see the other half of it, which is, well, it forces everybody to keep the wind turbines at peak performance all the time, which adds costs, which is why they're pushing back. It's this continual yin and yang of costs, and
it saves money over the long run. I don't think it's the financial incentives are there to keep your asset running as long as possible. So I think these guys have just made poor decisions because they're looking now at replacing their wind turbines halfway through their lifetime. I mean, that's not a prudent financial decision to save money on maintenance. So that's why I call it a cautionary tale, and I hope that people will take that precaution and say, oh, okay, we've got to invest in maintenance, otherwise we'll be stung in a couple of years.
But isn't the production tax credit driving a bunch of that? Like after 10 years, the production tax credits go away. So the value of your assets go away. So therefore, you would logically, if I'm an accountant sitting on a spreadsheet, say, I won't want to put as much money into these maintenance projects with these wind turbines that are not PTC ready.
So
isn't that what happens? I think the data backs that up.
Go over to the next column on the sheet and have their insurance company hit them with a massive penalty. then it makes more sense to maintain them better, right? So let the market correct it, but the market has to correct it. So if the insurance company, now that they've thrown a blade for doing something dumb, can penalize them or can make their premiums go up the next year because they've failed to be a prudent operator and maintain their assets properly, make them burn on insurance.
Isn't it a weird economic dynamic that we're in at the moment? If the PTC drops at 10 years, which is, I think that's right, it's either 10 or 13, 10 sticks in my head. At 10 years, your asset value goes way down, more incentive to put new wind turbines up. That's good. The OEMs love that. So from a PTC standpoint, they're there for 10 years. I'm going to refresh them every 10 years. Cool, right? But in the meantime, there are all these consequences. It's the Rosemary, what are the consequence bit? The consequence of doing that PTC, the way that it's structured today, is the maintenance goes away. And then you have problems. So is there a good middle ground? Either one of you. Is there a good middle ground that would get rid of this maintenance issue and keep these turbines turning, but also make the OEMs happy?
Yeah, it's all going to come down, like you said, Alan, to what does it look like on the balance sheet. So the middle ground has to be
that's what I get.
It has to be a struck balance between O&M costs, insurance costs, finance costs, and production costs.
I love Rosemary's answers because it's the engineering answer. Like, look, you idiots, you need to be keeping your wind turbines up and running. That's the obvious answer. Hello, right? And us engineers who drive cars for 25 years because we take care of them. Yeah, that's exactly what we do. And sure, that's just how sort of we operate, right? But that is not how the accountants operate. The accountants try to maximize profits every quarter, every year. And they have a different input. And I think sometimes us engineers get on our high horse.
Is there
me included? It's not just Rosemary. I'm the same high horse.
Is there
but we create these weird problems.
Is there an advantage to say think ERCOT, MISO, all the different the grid operators? Is there an incentive that the grid operators could put out to if they had uptime, right? Like its own private PTC type thing that says like if you say you can put 100 megawatts into the grid. If you can get me 50% uptime, we'll give you this. If you can get me 45, you get this.
Right.
And have it. I don't know.
Right. See,
and everybody's going to want it too, right?
The Rosemary's point.
Yeah.
Well, yeah. To Rosemary's point, though, I think the capacity factor with Dominion is a big problem. But at the same point, if the PTC were tied to capacity factor, some of this may go away by itself. It's just say, hey, we're going to have a capacity factor. If you want PTC, you have to meet a capacity factor, and we will extend your PTC if your capacity factor.
But how does so I don't know about
does that get you where you want to go?
I don't know about these tax credits, but how do they work? Is it that they pay you based on every megawatt hour that you produce, or? Yep. Yeah, so I mean, there is an incentive to have good availability because you get more megawatt hours produced. And I know in Australia, in Europe at the moment, I don't know what's going on with power prices in the US, but there is already an immensely strong incentive for everyone to keep their assets generating, because prices are so high that, wind farms and solar farms that are able to generate, they don't have increased fuel costs like all the fossil fuel producers or fossil fuel generators do. And so they're just making massive profits at the moment if they can keep their availability up. So it's certainly not true that there's no incentives in the system. I know every electricity market is different. But is this even a widespread problem? I don't feel like we hear about that many blades falling off turbines. Is that really an issue?
It's not just this issue. It's all issues with blades, all issues with maintaining these things. It's like a cultural issue, like a cultural in the wind industry that, like, a lot of times, Rosemary, and this is I've seen this many times, and I can understand why it happens. It's just very frustrating to see, like, wind farm X will have 50 turbines and they'll say, we've got $200,000 to put towards the blades this year. Okay. So you start working out there, you're fixing blades. And then all of a sudden it runs into 190,000 on the PO. And they're like, hey, you got 10 grand left, demob. And you're like, we've got some Cat 4 and Cat 5 damages over here that, like, if you don't stop these things, those blades are going to rip apart. And they're like, sorry, only 200,000 in the budget. See you later. And they just leave them run. That's a regular occurrence all across the U.S. Like, they just don't put any kind of love. I don't know any operator that has a whole lot of TLC for their blades specifically, because, of course, that's what I work in.
Yeah, everybody love your blades a little bit better.
Yeah,
and this problem would
tuck them in at night. Give them a pillow and a nice blanket.
Yeah, well, it takes a lot to make a wind turbine blade, so that makes me sad if people aren't loving them after they leave the factory.
Yeah.
Because they're made with love.
Yeah,
right, Rosemary?
they're made with love and a lot of people's, personal hand touch on them. So, yeah, look after your wind turbines.
Well, more to come. I think we're going to have to keep track of this as it goes through. We're going to see some big changes in the next couple of months. So we will keep following this news story.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS, so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
Well, there's a Norway-based firm called Worldwide Wind that is developing a new type of floating vertical axis wind turbine that is uniquely different than other ones I've seen, Rosemary. It's actually two sets of vertical axis wind turbines stacked on top of one another, and they counter-rotate probably to keep the moment of inertia down. And it's still on paper. We haven't seen anything yet. And the whole wind turbine, if you can envision this, is at an angle. It's got a 45-degree angle. So it's not truly vertical. It's like, I would call it a slanted axis wind turbine. Maybe I ought to patent that or trademark that. It's a slanted axis wind turbine. And it seems interesting because one of the turbines is the rotor and the other part's the stator. So they're counter-rotating. So the whole assembly itself makes a generator. It makes sense on paper. Now, there's been a ton of criticisms about this on LinkedIn. And so this popped up a couple of weeks ago. I sat on it because I thought this is crazy. No one's going to even bat an eye at this. And all of a sudden, on come the LinkedIn experts to say, that's crazy. That's the worst wind turbine I've ever seen. What are you talking about? And I don't think it's horribly bad. I think it's just another idea. When we were talking earlier about having some new ideas in wind, Rosemary, why is this a good idea or a so-so idea?
Well, I think the idea of vertical axis wind turbines for floating offshore definitely has some merit. And so I'll put this in the category of interesting idea to investigate further. It's kind of obvious why, if you look at a normal horizontal axis wind turbine, you've got a really tall tower and all of the weight is at the top of that tower. And, it just doesn't look like something that wants to float, right? Whereas if you take a vertical axis wind turbine, the generator can be on the bottom and you have most of the weight at the bottom. So, it keeps the center of gravity low, makes it easier to make a floating structure for it. So that's, that's true for any kind of vertical axis wind turbine design. This particular one, it's got the counter-rotating thing. So perhaps that's going to make their mooring system easier because, you'll end up cancelling out some torques. I haven't done any, free body diagram of it to kind of think that through properly, but that's at least what they're stating. They haven't made one yet. I think they've got, like, if you look at their website way down the bottom, they've got a photo of a small scale one, which is 2 of those they're called Savonius type, like a drag type wind turbine, which is just basically like a cup that gets pushed around by the wind that, you see them on weather stations and all sorts of places that need like a really durable, low efficiency generator. So I think they've made one of those at least. I did see in another article that the founder has once made a vertical axis wind turbine. It looks very different to the one that they're promoting for their floating offshore design. It seems he has made something. And then they've got some nice, computer generated images of whole wind farms of these things. But it doesn't look like they've even made a prototype, an onshore prototype of one. So, it gives you an idea of where they're at. But if you go through their list of benefits, it just reads like any other kind of revolutionary new wind turbine design. I've made a whole video about this actually with Paul Geip, who has a whole website, WindWorks, that tracks, I think it's wind-works.org. And it tracks all of the new wind, and he's been doing it for decades, so you can see like the rise and fall of, dozens of examples like this. And I had him come on my YouTube channel to talk about his list of red flags that he sees, over and over again in these, new designs. So some of the benefits that they're saying are real benefits associated with vertical axis wind turbines, and some of them are just these myths that keep on coming back and back. And because we don't actually see any industrial sized vertical axis wind turbine farms or even individual turbines since, the 90s, these myths never get disproven because no one ever actually gets to the point of, building a wind farm with these turbines. So maybe I'll just go through, I'm just on their website. So it's worldwidewind.no. I'll look at some of their claims and talk through those. So simple design, no nacelle, gear, cooling or yaw. And that, I think all the first ones, that's very easy to have a simple design when it's just on paper. No nacelle, yeah, sure. And the yaw, that's one people talk about a lot with vertical axis wind turbines, that, they don't need to turn to face the wind direction, that they're omnidirectional. And that's true. But if you look up cost breakdown of a normal wind turbine, the yaw system is somewhere between like 1 and maybe maximum 5% at like the very upper limit. And it's not something that I see fail a lot. I don't know if, Joel, you see a lot of your system failures.
Motors every once in a while, but that's...
Yeah. So I think this idea that they're omnidirectional, it's like, yeah, great. Like your system is not a big problem. It's not a big cost. Like, who cares? Move on. And then reduced wake effect and increased turbine density. This is the one people keep on going on and on about for vertical axis wind turbines, that you can pack them closer together. And it's similar to what we talked about last week with the, the turbulent wake that persists behind a normal wind turbine. And I mean, that wake is there because you've taken energy out of the wind. So if a vertical axis wind turbine is taking energy out of the wind, then it's also going to have a, reduced wind speeds behind it. That's just definitely going to happen. And this particular idea that you can pack vertical axis wind turbines closer together, it comes from one study that was done. It's a desktop study. They did some 2-dimensional CFD of a wind farm of three different vertical axis wind turbines, and from a specific angle, then that gave a better performance than a wind farm of horizontal axis wind turbines that are, basically arranged in the least efficient way. It's an interesting result that should have led to somebody doing some wind tunnel tunnel tests, maybe some 3D analysis, maybe a few more wind turbines in their simulation, maybe a few different angles, wind angles. It gets repeated over and over and over again like gospel truth, but it's nothing. It was an undergraduate student that led this study and, found an interesting result, but it's the starting point for research to find out if it's an effect, not the basis for, it's spawned about 50 startups, startup companies, as far as I can see, just this one undergrad student's, final year project. It's, that's kind of interesting to me that just keeps on coming up and up and up.
Yeah, it's true.
Yeah. What else about this? Sorry.
Well, let me throw the ultimate question, which is the Rosemary age of wind maturity. How long would this take to become reality? And they're projecting a 40 megawatt machine as early as 2029. So let's just use that as the baseline. When did you think they would have a 40 megawatt machine?
I mean, honestly, never. I know a lot of designs, vertical axis wind turbine designs that are looking a lot more promising for offshore, for floating offshore application. There's some weird features about this particular one. They've got their generator underwater. I mean, that's such a self-handicap that they've given themselves. You're trying to develop this radical new design, and you're going to put it in the water, and then one of your main maintenance components is underwater. So then what, you're going to dive underwater you're going to get scuba divers that are also wind turbine technicians to go under and maintain that? Are you going to have to haul these things out of the water, tip it over?
Maybe, yeah.
I don't understand the maintenance. And then just the normal thing that
Isn't that the case though, Rosemary? Mm-hmm. I think you raised a lot of good questions, right? Like some of the obvious ones, like how do you maintain it? And what happens if? Which is what vertical axis wind turbines have had trouble with for a long time. Horizontal axis wind turbines have gone through that birthing pain and reached at least teenage years in a sense of being able to like consistently produce power. That's a really difficult thing to do. It's a lot harder than people would assume. Yeah. And when you see anything that's happening within a decade at a 40 megawatt level, you're like, whoa. If I put if I gave Vestas a couple $1 billion, could they do that? Maybe. 40 megawatts is a big machine.
You can make a regular wind turbine 40 megawatts if you wanted to. There's no engineering, law or law of physics that you're gonna break. You could do it.
Blades?
You could. It just would be very expensive, and it's actually been trying to write a video script about that the last week about how big wind turbines are going to get, and all the scaling laws, and you have this problem, especially with the blades. It wouldn't be
how big?
Well, there isn't. I don't think that there is necessarily going to be a hard limit. It's an economic limit. It's about at what point do things stop getting cheaper.
A limit.
Yeah, but we're already at the limit. We're always at the limit. That's wind turbine manufacturer will design the turbine that can give the cheapest energy out, because that's how you win projects. And so it's been getting bigger because some of the considerations that there's. We have to wait and see the video.
How big?
But basically, things like the generator, the power connections, the installation, transport, all of that favors fewer big wind turbines. But then all the structural stuff, especially the blades and the tower and a lot of other stuff, shafts and things, that really favors keeping it small, because you've got the square cube law. Have you heard of that? Right. So as you scale a wind turbine, its power output increases with the square of the diameter, but the weight of a lot of components like the blades increases with the cube of the diameter. So there's actually, something to be said for keeping.
Yes.
If you just worried about wind turbine blade weight, you'd have tiny, tiny turbines everywhere. You could have a lot less blade materials involved. So
What
That's isn't that the dinosaur problem though, right? I mean, the dinosaurs only got so big just because they got so massive, the bone structures couldn't support it, right? So are we at dinosaur level, Brachiosaurus, Altothorax levels of wind turbines?
No,
are we there?
We're
The big
not.
giant ones. Are we
And
already
even when
there?
you look at
No.
wind turbine blades, the mass of the blades has not been increasing with the cube of the diameter over the last few decades. It's only been increasing with just barely more than the square because we've made technology improvements, different materials, getting better at manufacturing, knowing more about exactly how strong the materials are. So we have smaller safety factors because we're more confident of them, all that sort of thing.
Are you gonna make me watch Engineering with Rosie to find the answer? Is
Force
that
you
what's
to
going to
watch
happen
it.
to me here?
See you in front of
don't
it
get a
with your
preview either.
eyelids like propped open with toothpicks.
So here's a thought and a question. They're unrelated right now, but I'm just thinking about 2 years ago, the 12 megawatt turbine was the biggest one. Like the Vestas was putting a 12 megawatt out. Right now, that was going to be the biggest one.
Yeah.
Right now, Ming Yang has just put a 16 out. So that's 4 megawatts of growth in 2 years on the biggest turbines. And everybody's going to keep chasing that. So what does that mean for 2029 in the horizontal axis wind turbine space? Does that mean 22?
Well, we're going to have
24?
to wait till Rosie puts it out on the
That's right.
on the YouTube because we're not going to get answers
But
here.
you also get really
So,
different
Rosie, I got one more
results for onshore versus offshore because you've got totally different constraints. And then I think floating offshore is totally different design requirements and constraints again. And that's why, like, I don't see vertical axis wind turbines having much effect onshore or for fixed bottom offshore. But for floating offshore, I think that, you know, the requirements are shaken up enough that I think that, I mean, if you were starting from scratch, if no wind turbine ever existed before and you needed to come up with a way of generating electricity from the wind offshore, deep water offshore, you wouldn't arrive at the horizontal axis 3-blade upwind rotor design. I think that's clear. I mean, it doesn't mean that we won't end up with that for floating offshore because that is already so mature that maybe it is smaller increment to, you know, technology increment to just develop a floating platform that would work for that. But I certainly think that there's a chance for vertical axis to, you know, get in. I personally would, you know, if I was had a startup company on vertical axis wind turbines, I would personally want to develop as much of it onshore as possible. And I never, ever see any of these startups doing that. They've got a paper design and then they immediately launch to putting a prototype in the water, which, I mean, you're going to want to be very well funded to do that because, I mean, just look to wave energy industry to see a catalogue of, you know, probably tens of companies who have failed because they, some off-the-shelf component that they used failed offshore, waiting for a weather window for maintenance. They ran out of money and they went bankrupt. You know, like that's just happens over and over and over again. And I don't know. I think that there's a lot of money around now for clean energy investment. And it seems like all you need is, you know, some sort of basic level SolidWorks modeling, rendering skills to be able to get millions, it seems.
To get some money.
Yeah.
Yeah. Rosemary, for like taking this idea of this counter-rotating vertical axis turbine with the stator inside of it, doubling the power up theory, whatever. Have you ever seen someone take a horizontal axis wind turbine, 3-bladed, and then put on the back of it, do the same concept, and then a negatively pitched blade the back way?
Yeah, they did that in the early days.
Does anybody do that?
In the 70s or 80s or 90s, yeah, they did that. And you can get a bit more energy out, but not enough to, add the cost to it, basically.
So what Rosemary has announced today is she is actively saying that vertical axis wind turbines are worth looking at.
For floating
I can't
offshore.
believe I'm hearing this. Quite honestly. Okay, right. Let me rephrase it. Floating offshore vertical axis wind turbines are cool and that they may be the future of offshore wind. And that's Rosemary's stamp of approval. I can't believe that actually happened today. Wow. So that opens up all kinds of designs that we've wouldn't have otherwise seen. Just getting an engineer who's a serious engineer who's been around the industry a long time, like Rosemary, to say there is a space for that is news.
I don't have a lot of company
most
in
engineers
that
say
optimism.
No, I'm not saying
No. I mean, I'm saying there's not a lot of other wind energy engineers, mainstream wind energy engineers who think, oh yeah, that's a great idea. And I think part of the reason is because when you see, a company like Worldwide Wind or I don't know, C12 is another one. There's quite a few floating offshore vertical axis wind turbine companies. And when you look at each one individually, you're like, oh, that looks like there's a lot of dumb aspects about that. But if you actually start from scratch and you're like, okay, we want floating offshore wind, how are we going to do it? I do think that there is something to be said for, I like vertical axis wind and multi-rotors as well. Those are the two things that I think it's worth investigating. But if you look at the companies that are doing them, they're never full of, people with a lot of experience, and they seem to be making questionable decisions. And I think a lot of it is because you have to have these pretty pictures to get investment. And so they jump straight ahead to the 40 megawatt version rather than, make some 500 kilowatt versions and install them on the land and, prove that most of their claims you can prove on land. You don't need to go offshore to, prove that the counter-rotating thing works. Or that, you can, get double the efficiency for the same land area from, having an array of these things. So I think that's the reason why most people write them off.
Rosemary, I'm getting a text from the SEC at the moment, Joel. It says, never listen to the investment advice of an engineer. That's actually good advice. Thanks to the SEC for texting me, because some of that didn't sound like investing advice. I would say let's tone down the investment.
You think it sounds like investment advice?
But Rosemary does give a lot of good engineering advice. Yes, it sure does. What? There are some of these guys that are idiots. I don't say guys, but there's some of these companies that are idiots, and there's some of them that are pretty real because they have a vertical axis wind turbine that may make sense on floating offshore. Question is which one, right?
Oh, well, then you need to hire an engineer to help you figure that out.
I'm not going to ask because I do not.
I'll put my hand up.
Well, then you have to go to partalopeconsulting.com and hire yourself an engineer to take care of those questions, because clearly it looks like there's an opening in vertical axis wind turbines, which is quite honestly shocking. Rosemary, I never thought I'd say that, but that's cool, right? I mean, there's a new space for engineers to pursue and to maybe make wind turbines even bigger and better than they are right now. That's always good. We'll take it.
I don't like to instinctively rule out anything new. I think it's very easy to become cynical like that, but and say, we have something that works, Rosemary, and everything new is dumb.
Rosemary, come on. We've been around. We've known you for a long time now. Yes, when something new comes out, it does get the Rosemary. I don't know.
But most new ideas are bad. I mean, most startups fail, and you've got to somehow.
That's true.
You've got to somehow be able to cut through all the stupid ideas, but keep your mind open enough to be able to recognize when there is a reason why this could work this time.
That's going to do it for this week's Uptime Wind Energy Podcast. Thanks for listening. Please take a moment and give us a 5-star rating on your podcast platform. Be sure to subscribe in the show notes below to Uptime Tech News, our weekly newsletter, as well as Rosemary's YouTube channel, Engineering with Rosie. And we'll see you next week on the Uptime Wind Energy Podcast.